Okay? So, in addition to what we discussed earlier for the problem analysis, so again, we have the problem. Okay, starts the problem, and then we analyze the problem. After analyzing the problem, we perform the algorithm by using either pseudocode or flowchart. Once we implement the algorithm, we can already do the coding using the C++. So, when we code it in C++, okay, so again, we are going to perform and use preprocessor directive, and then the compiler will compile it, okay, to test if there are syntax errors. So again, if there are errors, we edit the code or we debug it, and then go and proceed again to preprocessor, and then go back to the compiler. And on this case, if the compiler have no syntax errors already, okay, again, it will perform and create an executable code using the linker and the loader, and finally it will execute. Okay, so again, if it's executed and we have errors, meaning this error is not really the syntax error but rather the logical error, okay, we can already do the coding, or again, we can perform the analysis, what's the problem when we code, or there are still problem logically, like for example, if you use the logical operations or the comparison operators incorrectly. So you need to perform again the algorithm design before you do the coding. But if there are no problems during the execution, that means we can actually get the correct results. Okay? So again, if you have any concerns or challenge with this particular topic, you may consult me during our time and during my consultation time. Okay? So again, you need to thoroughly understand the problem, and then you understand also the problem requirements. Okay? So let's say, for example, the require user interaction, how are you going to manipulate the data, and what is your expected output. Okay? Then if the problem is very complex, you need to divide it into sub-problems. And then when you divide it into sub-problems, you go back to understanding the problem requirements. Okay? So you need to again require what's the user interaction, how are we going to manipulate the data, and for each sub-problems, what must be the output. Now, if problem was broken into subproblems, you can also perform and design algorithm for each subproblem. Then, if all those subproblems are okay and correct, you can actually test the algorithm, all our algorithms for a sample data. Okay, and most of the time, most of the time, you need to use mathematical analysis. Okay. So again, once the algorithm is designed and correct, and you already verify it by using your algorithm, you can already write the equivalent code in high-level language using C++, of course, this time. And of course, you need to enter the program using the text editor of that particular compiler. So again, make sure that you can actually get this bloodshed dev C++ for free in the internet. So again, we use bloodshed dev C++. And then you get the version 11 point something. Okay? Okay, so once you enter the code to an editor, you can actually run the code through the compiler. Okay, again, compiler will translate it automatically into machine language. So if the compiler generate errors, so that means you need to look at the code and remove those errors. So again, you go back to the editor and then you debug it. And then run again the code through the compiler. So hopefully when there are no syntax error already, you can actually generate the equivalent machine code, and then the linker machine code will create the .exe file for you. Okay? And then once we already created the .exe or the memory for execution, we can already execute the program. Okay. So again, the compiler guarantees that the program follows the rules of the language or the keywords. Okay. Like for example, in C++, we use C out and C in. Okay. So that's actually the language of C++. Okay. So take note that compiler does not guarantee that the program will run correctly because as mentioned a while ago, okay, it is syntactically correct, but when we already execute and run the code and we input something on the code or we input a data on that particular problem and the result is incorrect, it's not anymore a syntax error. Okay? And that is actually what we call a logical error. Okay? So by next meeting, I'm going to give you an example of this on how to perform an algorithm in using flowchart and pseudocode. Okay, and then I'll be giving you also the discussion of the basic C++ elements already. So, and how are we going to perform this example in a flowchart and in pseudocode? Okay, so this one, I'm going to give this, and this, and this. Okay, although here's already the equations, but how are we going to make use of an algorithm and how are we going to use the C++ containing these syntaxes or these keywords in C++. Okay. Now, let's proceed to programming methodologies. So there are two popular approaches to program design. We call it structured design and object-oriented design. So mostly CS126-8 will use structured design. Okay. So structured design is actually dividing a problem into smaller subproblems. So for structured programming, we use what we call the word functions. So this is on week 10 or week 9. Okay, user-defined function. Okay, so it implements a structured design. When you say structured design, the approach is actually from top to bottom. Okay, and then stepwise refinement. So it's like the associativity is always from left to right, and then it can perform also modular programming. As mentioned a while ago, we call it as a function. Okay? While object-oriented programming, it identifies components called objects and specify relevant data and possible operations to be performed on that data. So in this case, for object-oriented programming, instead of using function, they use methods. Okay? So when you say object-oriented programming, okay, it implements OOD. OOD stands for Object-Oriented Programming Language. Okay. Actually, C++ is both structured and also was designed to implement the object-oriented programming. Once you finish CS126-8, okay, and you pass the subject for 126, continue to 127, you will be able to differentiate already the structured to object-oriented since on 127, we are going to perform and discuss some of uh, an object-oriented syntaxes for C++. Okay? So again, ANSI, ISO Standard C++. ANSI stands for American National Standard Institute, while ISO is International Standard Organization. So again, C++ evolved from C language. Okay? C language was designed by Dennis Ritchie, while C++ was designed by John Strauss Stroop, okay, at Bell Laboratories. C++ programs were not always portable from one compiler to another. So meaning to say, there are different types of compiler for C++. Okay, so not all compilers will be portable when you, like for example, you use Visual C++ and then you were going to transfer it into Bloodshed or Bloodshed Dev C++. Some compilers are not always the same, okay, when you run and execute the program. Say, for example, I use void main syntax because I use Visual C++. Okay, so Visual Studio C++ accepts void main. But for Dev C++, void is not accepted for the main. Okay, so that means, again, C++ were not always portable from one compiler to another. Okay, and then in mid-1998, the ANSI and the ISO organization, okay, standardized C++ language. Okay, so that's our chapter 1. In summary, we discusses the computer systems as hardware and the software, and then the computer, we define the computer, the central processing unit, the primary storage, and the operating system. Okay, and then we discusses various kind of languages such as machine language, assembly language, and high level. We also discussed the algorithm, and you already identified two types of algorithm, which is the flowchart and the code, and how we solve problem solving in 3 steps. And then we also defined and differentiate the structure design to an object-oriented design.